In this video, I'm going to be talking to you about the Foundation Framework collection classes. We've already talked about the Foundation Framework primitives. We talked about strings and dates and numbers. We're now going to talk about collection classes, which allow you to store multiple collections of items. So if you remember from the previous video, the Foundation Framework defines a base layer of Objective-C classes, which you can use in our application. So the aims of this video are to understand the Foundation frameworks, to look at how we use collection classes for storing other objects, and a little look at something called introspection, which is very important when we deal with collections. The idea is a collection class stores a collection of pointers. So every item we add to our collections must be an object, but it also means that a single collection, such as an array, can store any combination of different objects. The problem is, if we're storing different sorts of objects in our collection classes, we need to be very sure what those objects are before we try and use them. We're going to be talking about three collections today. We'll talk about sets, which are used to store an unordered collection of unique objects. We'll look at arrays, which store an ordered collection of objects indexed by numbers, and a dictionary, which stores objects against named key pairs. It's also important to understand that all three types of collection class come in two different flavours. The standard type is immutable. So for example, if we create an Nsarray, we can't add or remove indexes. However, there's another type of collection class called a mutable. So we have mutable sets, we have mutable dictionaries, and we have mutable arrays. And with mutable collections, you can add and remove any indexes that you wish. So let's start off by talking about introspection. Introspection is important when we start storing pointers in our collections. Because it's dynamically bound, our code might compile fine, but when we try and retrieve, for example, when we try and retrieve an object from our collection, and we try and carry out actions on it, if it's the wrong object type, then it's going to crash our program. And this is where introspection comes in. There's a couple of very important methods that form the introspection toolkit. The first one is there's a method called isMemberOfClass. And this returns true or false depending on whether the object you're looking at is a member of the specified class. So if we're working with strings in an Nsarray, for instance, when we pull a pointer off, we can look at the object and test to make sure it's a string before we start doing string style methods on it. The second important method is isKindOfClass. Now this is important because it determines whether the object belongs to the class or a subclass of it. So it's slightly more flexible than is a member of class. The third method is to test whether it responds to a particular method. So we can say if it responds to selector add object, then we know that the addObject method is supported by this object. So it's a very useful method to understand. So let's move on to our collection classes. The first collection we're going to look at is called an NSSet. And it stores static sets of distinct objects. Here's an example where we create a set with two objects in it. Two NS strings, sleepy and dopey. And where we can also create a set from an array. And if we create a set from an array, it removes any duplicate items, any duplicate objects. We can also create a set by taking an existing set and adding new items to it and creating a new set from that. And we can either add objects to our existing set to create a new set, or we can merge two different sets together. So a very important property is count. And all our collection classes support the count property. And that returns an integer value of how many items are in the collection. A useful method for set is contains_object. So we can search to see whether our set contains a particular object. And it returns true if it finds it and false if it doesn't. We can also look for subsets, intersects, and to see whether two sets are the same. The second collection class we're going to look at is called an Nsarray. An Nsarray is an ordered collection of objects which are indexed by integer values. And NS arrays are immutable, so once you've created an array, you can't add and remove new indexes. Obviously, it supports the count property. You can retrieve an object to the particular index, and also for building stacks and queues, you can retrieve the last object without having to know what index it is. So two ways to create an NS array. You can either allocate it with the objects you want, or you can call the class method array with objects. Both work in exactly the same way. So let's have a look at how we access different indexes. Because all arrays start at index 0, to get the first item off the list, we'd call the method called object@index and pass it 0. For the last index in the array, we would call the last object method, which returns the last index. Another important concept is working between strings such as CSV strings and arrays. So let's start off by creating an array which contains 2 indexes. We can call a method called components joined by string. We specify the separator we want, and that returns all the objects from the array as a single NS string. And if we want to take a CSV file, for instance, we can convert each row into an array by calling the component separated by string on the CSV string. It's also handy to be able to loop through arrays. So in this example, we are looping through the people array, and we're pulling each pointer out as an NS string. We're using introspection to make sure that we are dealing with a string, and then we can log each of the array indexes to the log file. So a key variant of an NS array is an NS mutable array. And an NS mutable array adds the capabilities to be able to add and remove indexes without creating new arrays. So here we have an example. We create an empty NS mutable array, and then we call the add object method. And there's a variation where you can add object at index, which pushes that lower index in the values down one slot. Another feature is sometimes if we've got an array, we want to make a mutable copy of it to be able to edit it. And all we do, we call the mutable copy method of the NS array, which returns an NS mutable array. We can also remove objects from NS mutable arrays. So again, we can remove object from indexes, and also we can remove the last object from the NS mutable array. The next collection class is called an NS dictionary. An NS dictionary is a collection of objects referenced by unique keys. Each key value pair is called an entity, and one object represents the key, another object represents its value. And we'll use this extensively when we deal withplists and core data in the next lab. So here we have an example of how we create a dictionary. And as you can see, we pass it pairs of objects. In this example, the name key references the mark string, the prog key references comp sci string, but the values could be anything. They could be, in this example, they're NS strings, they could be anything at all, including NS dictionaries. So to access a dictionary object, we have to tell it which key we're looking for. In this example, I'm retrieving an NS string from my dictionary by specifying object for key name. So that should return a string mark if we use the previous example. Just like the NS array has an NS mutable array variation, the dictionary has an NS mutable dictionary variant, which means we can add and remove objects. So in this example, we create an empty NS mutable dictionary, and then we call a method called setObjectForKey. And as you can see, we specify the object first and the key last. So that's an area which people get confused about. People are used to specifying keys and then values. So it's value for key. And we can take an NS dictionary and create a mutable copy in the same way that we work with arrays and mutable arrays.